Alright guys, welcome to the channel. We're going to be solving question 63 from the second chapter of the Beer&Johnston textbook, Engineering Mechanics, and we have a color A that is connected, as we can see, to a 50-pound load that can slide on a frictionless horizontal rod. And by this frictionless, the question is referring to no horizontal force need to be considered in this question since the surface is frictionless. And we need to determine the magnitude of the force P that is required to maintain the equilibrium. And when we have equilibrium, we know we have sum of all forces equals 0. The question is 2D, so we have sum of all forces in both x and y is equal to 0. So we have two different conditions in here. We have two different values for x. One of them is 4.5 inches and the part B is 15 inches. So we're going to start with the free body diagram of color A. So we have the force P. We have the tension in the cable, since we have one single cable that goes around that pulley and is attached to 50 pounds. So the tension in the cable has to be equal to 50 pounds. And we also have a normal force applying to the color, and since the question is saying that the surface is frictionless, we don't need to consider any horizontal component. And call our x and y in here. So no x component for the color, and we have to figure out the force P. Let's go with the part A where our x is 4.5. And we can call this angle here alpha. So if we start with sum of all forces in x direction, we have t cosine of alpha minus p is equal to 0, or our p in here is t cosine of alpha 50 times cosine of alpha. And all we need to do in here is just to find the alpha. But since we have all the dimensions in the question, it's pretty easy to find the alpha. What we're going to do for finding the alpha. So if we look at this right triangle, this is the angle alpha that we call. This side is x, which in the A part is 4.5, and we have 20 inches in the other side of this right triangle. And cosine of alpha would be, so if we want to find the hypotenuse, we have the square root of 20 inches squared plus 4.5 squared. So we're going to have 50 times cosine is the adjacent over hypotenuse, 20 squared plus 4.5 squared. And we can find our P in here. 50 times 4.5 divided by square root of 20 squared plus 4.5 squared. That's going to be 10.98 pounds. And that's the answer for the A part. And for the B part, we basically have the same thing. It's just our x this time is 15 inches. So we're going to do the same thing. We have P is equal to 50 cosine of alpha, but the alpha this time is different. So the only difference in the B part is that we have 15 inches. So our x in here is 15, and here we have 15 squared 2. So we have 50 times the adjacent, again we have 15 over square root of 20 squared plus 15 squared. Let's calculate this. So 50 times 15 divided by square root of 20 squared plus 15 squared, which is going to give us 30 pounds. And that would be the answer for the B part of the question. Hope everything was clear. We can also solve this question with the trigonometry too, and actually it's a good practice to see how we can solve that with trigonometry. And yeah, you guys take care. I'll see you in the next video.